You have to fill it. So we're just going to walk through, and this is kind of also your review for the exit ticket, the first exit ticket. Turn to your notes, or if you weren't here, the page on isosceles equilateral triangle. My guess is 317. Oh, that's the lesson. This is page 320, but I want you to see the lesson. For those, mainly for the, if you have notes, just turn to your notes. Don't really need. But if you don't have any notes, you didn't write anything out. It was a pretty short lesson, and some of you probably weren't here. Oh, it was 316. Three. Should have started on three. It's always starts on five. Oh. 315. That page is really all you need, and I'm going to kind of go over here. If you have notes, use your notes. I'm about to ask questions, and I need people giving me correct answers, so I don't get mad. We know something is true, but we're given that something is true. That's the easy part in this triangle. We're on number 8. What is it that we are given? Raul, take your earbuds out, please. So that is what these marks mean. You should have that down by now. I mean, we did this way. Well, my board's not cooperating very well today. So. That means the left and the right side are congruent, the same length. Now, his question was, I don't know that this is equal to that. There's no congruence mark there. There's no information over there, so I can't do anything with that. 60 is about an angle. So if I didn't say this in this class, write this down. You never put information about a side and information about an angle in the same equation. Never. They're two totally separate things. You will never do math with a side, like numbers about a side and numbers about an angle in the same equation. Never, 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 never. Totally different. So never put numbers, variables, whatever that are the lengths of sides, measures of sides, in with numbers or variables that have to do with the measures of angles. No situation where you do. Oh, okay, I have enough. So when you're done with that, just gonna put the pencil down. So I know. Or, oh shoot, I don't know if I have enough exit tickets for everybody. Hopefully, some of you might be forced to do a harder exit. See. All right, so again, that's a big thing that I saw when I graded recently. I don't remember if I had said it in this class or not. So now, with that in mind, he said, I don't know. I don't know that those are congruent. There's no mark. I don't have information there. I can't use the 60. Well, what in the world's going on? I said, do what you know. So what do we know besides the fact that now we know the left and the right side are congruent? Damon, you remember? You have your notes from your last class and your state notes. Yeah. Oh, wait. That's actually it right there. What is that saying? You kind of have some of the markings in that figure that we have up here. So what can we say is also true in that figure? Look at the markings we have in the left triangle. So what's true? Well, the markings though, not the number. Like look at your markings in that triangle. Where else do you have markings that we don't have in this? bottom, right? So what are they saying in that picture? Your picture. What are those markings saying? Say it again. If we know the left and right sides are congruent, then we know the two bottom, the base angles are congruent. That's an isosceles. We would also be able to reverse that. If we knew the two base angles, the two bottom angles were congruent, we'd be able to say the left and the right side are congruent. I don't, number 9 is not like that, but you'll see somewhere they probably have. So there was another thing I told you the other day that I didn't love, and now I'm not changing it. I'm giving you a different way to do it. And I might have even said the other way in this class. I don't remember. So if we have a triangle, my board is not cooperating. And I have no idea what's going on. I've tried recalibrating it. That's not working. So we have a triangle that's like that. So again, we know two sides are congruent. You have to make sure you make the correct angles congruent. It's not always the two bottom angles. It depends on which sides are congruent. I told you never use the the angle in between the sides. I think that's what we said. That's never one of the congruents. I don't love it because there's an easier way to do it. I think. Take your triangle. So again, we said if the left and right side, this is the way you always see the lesson start with an isosceles triangle. They always tell you the left and right side are the congruent sides. So therefore, the bottom two angles are always the angles they make congruent. And they would be the two that would be congruent. So let's just do what we did for rotations. Not that. Oh, how am I going to do this then? Oh, there we go. That worked. Yeah, that worked. Just take your paper and wherever the two marks are, make it the left and the right side. Turn your paper until it's the left and right side. Now mark the angles that are the bottom two angles, because once you have the congruent sides of the left and right side, the bottom two angles will always be the congruent angles. Now turn it back, to the way it would be so that the numbers are back to straight up and down the way they should be. And now you know which angles are. Again, if you just can pick it out and you just say, well, I know it's those two, that's fine. But if you struggle visually to see it, if you can't remember what was it about the angle between the two, do I use that? Do I not use that? Just turn it, just memorize this. When the left and the right are congruent, the bottom two are congruent, and then turn your page and make the left and right the two congruent angles and mark the two bottom as congruent. And then turn your page back. I think that's a lot simpler. It's not very mathy, but it works. All right, so with that in mind, we know the two are congruent at the bottom. What do we know? Sage. What do we know about the interior angles of all triangles? Oh, come on, yes, you do. One of the most common things we say, certainly this number is one of the common numbers, but so the interior angles of all triangles and so we know that's 60. So again, the interior angles, in this case, we know one of them, 60. I don't know either of those, but I know that they're the same, right? We just said they're congruent. So if we don't know an angle, what can we use to represent it? Variable, right? So I'll make it X. I'll put the degree symbol. Well, if that's X on the bottom left, what is it on the bottom right? Christina, if this is X degrees, if I just said, well, I'll just use the variable X, what can I put on the right bottom angle? Y is. Yeah, you do. What are the red markings telling us about the two bottom angles? Oh, girl, I'm gonna start checking your ears. So if you don't start paying attention, I'm gonna start checking your ears. Well, then you should know what you said. We just put them in there. What is true? What are those marking things? You definitely should know what marking. The red marking, that marking, and that marking. You know what about those things? All right, let's back up. What does that mark mean about that? Or what do those two marks mean about the side? So what are the two red marks in the angles mean?
At the end.
No, they're congruent. Same thing.
Oh.
It's just curved. We just curved them when we put an angle. I don't know why. I mean, I guess you could make it straight, but yeah, you just curve it. Same thing. So we know those are congruent. They're the same. So what can I put in the bottom right? Bottom left is X. What's the bottom right?
X.
So I know that's X because they have to be the same number. If I use the same variable. Now I can go back to, well, I know all three of those. Interior means inside. Go over that in a minute because that was something a lot of kids missed on that green quiz, which I was kind of surprised about. 60 plus X has to add up 20. So solve that out. Do the algebra. Already got it? Call in. Let everybody take a minute. So again, the whole point behind me taking a long time on this is do what you know. Don't try to jump to solutions one step at a time. Oh, I know those two bottom angles have to be congruent. Oh, I know all three inside angles have to add up to 180. Do what you know. Because in a second, you'll be like, oh, now I see right. If you didn't know. Do you have a question, Delaney? We'll get there. But again, you can't jump straight to that. Because that's about a side. And right now, we don't know that this side is congruent to that. There's no mark there, right? We don't have anything over here with the ones that are congruent. So we're just doing what we know, which is what you have to do in this. There's no way to jump to the final equation. I mean, you could guess, but I don't really remember. Oh, yeah. So what do we get, Joseph? So X would have to be 60, right? So now I don't even really need any markings. If I know they're 60, I can write in 60. Well, what kind of triangle is that really? If now I know it's 60, 60, and 60, that's what? Now I know it's an equilateral. So what else is true about an equilateral triangle? That should be in your notes. Everything is congruent. Not only are those three angles congruent, the three sides are congruent. Now I do know that is equal to them. So again, a lot of you want to just get. So we solved and got the 60. You good with that? So 60, 60, and 60. So just the definition of an equilateral triangle is all the angles are 60, right? They'd all be the same. But what's also true, if we know all the angles are the same in an equilateral, what's true about all the sides? That's just what an equilateral triangle is. All the angles are the same, all the sides are the same. So if I know those two are the same, actually this is also the same because it's equilateral. So now I know that is equal to that. That's when we bring the 3x and 80 back into it. Again, a lot of you would just guess that because that's one of your go-tos, just set two things equal. So you would probably guess that. But technically, you have to know why they are equal in order to set two things equal. All right, so I'm not even worried about solving it out. So go ahead, practice for like 5, 10 minutes. Do the exit ticket. If you aren't super comfortable, you can just do an easy 1-point one. There's no math involved in the 1-point exit ticket. You just have to match up the angles inside correctly, and then there's just a number that you would just have to write down that matches the variable or whatever. If you want a 2-point exit ticket, it's a little more like, actually, it's probably more like this. Yeah, probably more like that there, where you have to understand what's congruent, but then you also have to set up an equation and solve for it. So that's probably what the 2 point is like. And then the 3 point, I don't really have an example of that, but it's not just a triangle. It's an image with a triangle in it, but also something else. And you've got to know another old concept that we've used a lot. It's not anything you shouldn't know. I just am giving you options. So you get 3 points for that one. I don't I don't know. I know everybody hasn't gotten it. I feel like most people have, but I could be wrong. I haven't graded them. Just going based on their reaction. There were a couple of people that tried it that were like, "Can I get the 2 point?" What you choose 3 point, I'm not then changing out and doing all that. Everybody. Kind of depends on where your grade is too. If you're at a 70, for example, 1 point may not do any good, especially if you're not planning on coming in and doing any retakes. So you might as well try one word. Right? Risk reward, right? There's no real risk. If you're at 70 and there's a bigger reward. Oh, let me do attendance, and then by the time I do that, we actually no, I'll give you a few more minutes. Let's see. We get out at what? 11:36, right? Oh, 8:10. Oh, yeah, I always forget that on block. So what's that? 1878. I'm gonna ask you guys that question. Hmm. Wonder how many people in class if I said, I want you to put on the timer for me an hour and 23 minutes. It doesn't take hours. Hmm. Not hard, right? But I've sometimes it works. Eight, stick to them. Yeah, well, again, it's not that. I would say it's most like that. When you visually, like, I guess it doesn't matter as much in this. I would, I would say, yeah, probably most like that. Then it's probably been the most popular one today. But again, they didn't know what it was like. It's just the one I would say most people were choosing. I was just telling the girl that came, she wanted me to go to the blood drive during my planning. I've got probably, and this is not an exaggeration, 500 things to drink. I gave you free retakes. I have to now go back and regrade one of the quizzes because I made a mistake when I graded. I forgot I had a second, I didn't forget. I didn't remember that on the second version I had changed something else. I didn't really, I was just looking for the correct answer, the same answer on like one of the problems. I was looking for the same answer. So if I didn't see it, I marked it wrong. Well, it turns out there were two answers. There was a second version of that problem. Got to go back. It won't affect tons of people, but I still got to go back to every quiz to look at them. So I got to fix those. I've got who knows how many exit tickets. I mean, we did 2 exit tickets in every class yesterday and today. We did exit tickets Tuesday. Still have exit tickets from last week, I think, that I haven't finished. So I haven't had my planning in this week. It's today. So after this class, I'm done for all of it. Well, and then that's the other thing. I've had kids come in at lunch every day for retakes and after school every day for tutoring and retakes. So I haven't had any time to do it during lunches or after school. So yeah, moral of that story. If you don't have the problems in your book, does everybody have their book? So it's page 328 through 13. 328 through 13 were the problems. I don't think I told you that. So I put them up on the board, but I forgot to actually tell you. There you go. Those 328 through. Um, Well, 9 and 7 would be more like 1 point. None of those are great. I really hate these problems. I'm just gonna tell you, I hate them because it turns out every single one of them is an equilateral triangle. There's no isosceles triangles. You don't know that initially, kind of like the first one we just did. I don't know why in the world they did that, but they did, which I hate. Yeah, 320, 8 through 13. Yes, maybe. If I need glasses. Oh, what? I will say, I think there's a problem that's wrong with the book that cannot be solved. A student, one of my, again, probably arguably my strongest student, 320. Yeah, one of my, probably my strongest students showed me a problem. He said, I don't know how to solve this, and I don't think you can. Like, they don't, again, you could guess, but I don't think they want you to guess in it, but they don't give you enough information. So, actually, let's look that up in the, well, you got to put it in. Yes, ma'am. Perhaps. Why did we uh, it's on. Oh. Yeah, the three integer, right? Always. Any triangle. Yes. Because all triangles, the three integer is 180. There's no exception here. So you maybe, when you solve out, you may have to get the right number that makes them, but all triangles. I don't need to know any numbers. I know all triangles. Oh, you're saying when you plug that number back in. I actually didn't do that. Somebody told me that and I just wrote it down. I didn't know. 39.5. Well, then that, so. Did I say 39.5 is the angle? So again, what's the angle? You're doing two different things. Solving for x is one thing. You have x. What's the measure of the angle? That's actually this question. The angle. The angle. Just next there. There. To get the angle, then use that number twice plus the top end. And I bet you get those. Right, Joseph? No, it just gets solved right. I'm like 99%. Believe myself on out. Imposible. Imposible. You have to find that angle. That angle is not there. What is that angle? Nope. 2 times 3. That's what 2x means. 2 times x. So we don't use 39.5 for the angle. That's just x. Then if you do that, and I'll let you get to it. Oh, there it is. Show how it's small. That's weird. Look at your problem. Keep your late. Oh, actually, I guess I'm supposed. Oh, it's 3:20. That's not too. I didn't think this was great. This is back up. Yeah, I mean, just I'll tell you one thing that's wrong. Even if you don't understand why you can't solve it, it says solve the why. Still not. That's admit they printed wrong. You can't solve technically you can't solve for X either. It's kind of like what I showed you. You can't just set those two things equal. That's, and it's two of them, so I feel like there's supposed to be something else. Normally you don't do two first, like one first. Then if there's another two sides, you use two on those at the top. If one first, you won't feel like there's something missing. First of all, they don't apply to trends. Somehow you have to be able to prove that this side is also congruent. We don't have any information about angles. We're split with the students. So he's right. There's nothing in there. That is weird. I'm gonna go show that to. I'm gonna go show that to like really smart. Oh, yeah. That's a waste. That was a waste of my steps. Yeah, it's up there. Let's go ahead. You know, I it does track them, but I don't. I used to get at a company I worked for. You used to get for hitting certain goals and stuff. You'd get points and build up points, and you could buy stuff with it every year, just on a yearly basis. I got enough points to buy like $200 in Amazon gift cards every year. It was great, just for getting like steps in. Like the company I worked at, actually before I started teaching, they did all kind of they had a lot. So, so we just have a manual. Let's go ahead. I mean, unless somebody's like, no, I need more time, you can always just choose the 1 point question. That's as long as you understand how to find, like, for example, oh, don't forget if there's two numbers, that is also a way to tell you that the sides are congruent. Instead of doing marks like this, actually, I'll just redraw that one. So look at number 11. So 7 and 7 is another way to tell you that those two sides are congruent. So what you could do, like we said, if I want to make it if I want to make those two the left and the right side, well, I didn't think about it being left and right upside down. Hopefully you understand. That means you have to turn that image. Oh, and make the left and the right side the two congruent sides. If you want to put in congruence marks, that's not a bad idea to make it look like that. Now I know, again, you could have done this at the very beginning when you saw 7 and 7, done that. Now I know it's the two bottom angles. So once I know it's the two bottom angles, then I can turn it back. That's fine. We'll leave that there. So then you turn it back, and now you know the two angles that are congruent would be these angles up there. Close. And it winds up being another equilateral triangle. It's literally the same question as this up here. Only you're solving for an angle in one of the sides, which would be 7 because they're all the same. That would be like a 1 point. Oh God. This M is not a variable. It's a unit of measure, like this, where it says 7 inches. So I didn't never ever thought about that being confused as for a variable. Student, and I'm sure it has been, but for the first time today, we've used this book for 5 years. For the first time today, a student, or yesterday actually, was like, I don't understand how to solve for the M. You don't. It's not a variable. It's just saying 3 meters is what an M stands for. It's like, inches or centimeters or millimeters. You don't do anything with it. If you unit of measure, you would add on to your final answer. All right. So does anybody want to try the 3 point? Three, three, three. Anybody else want to try the 3 point? 3 point? All right. I don't know what I'm talking about. You were going to get it anyway, so it didn't really matter. Joseph? 3 point? Do you? All right. I like it. You've been paying attention. It's just, it's not. It's something that wasn't part of this lesson. You haven't seen it in a while. But again, it wasn't like it was months ago. It was within enough time where I think you'll remember what you need to do. Oh, did you say three? Yeah. Oh, you gotta put all your stuff up though. It's not open note. So just close it down because you'll be taking a minute. So I just close it. So you need it again. You don't have to put it up. Just close all your notebooks. The threes. We do have more another lesson to do in a minute. After I go through a review of what people missed on this. Any other threes? You have your hand up? No. Ah. Oh, so there's a 3 point option, Aiden. I think you might have been out, or were you in here when I said that? Okay. You don't want the three? All right. Thought you might go for the three also. I think more people went for it in here than any class. All right. Actually, I can just walk around with all of these. What do you want? Toast? What do you want? Toast. Oh, there it is. Two. Toast. You got wrong. Three, two, or one. Two. Look at you go. Two. Two. Didn't want to do three? That's the reason I like it. But all men is so two or one. Dos. Two or one. Dos. Dos. Right, close the book. Keep it out. Might be bad. Two or one. I really don't know. That's what we were here for. Probably could do the two. You paid attention, although you kind of didn't pay attention for through the whole thing today. But anybody not get one? Let's show all your work. I really don't know the answer. I can look at it and set it up like I don't know the answer. The grade is I can compare you. You have the same one as well. You got the same one. And you got different answers though. And I'll just tell you, you got a different answer. I'll get some. I'll honestly set up. Yeah, there was more to it than what we did. It's not. I'm only guessing it was. Why did you reach on the screen? It is. We don't know. They can't find it. This one and that one equal that. It's either 3 internal equal that number. No, that's it. Well, or these 2, which is these 2. No. We'll see where your grade falls. It's you are close enough to the next level up. I might try that. Tomorrow we're doing a bunch of it. So tomorrow we'll probably do at least for everybody, even if you choose 1.1 probably 3 points. It might even be 4 or 5. Got the same thing Elijah and Melinda got, so that's a pretty good sign. I have not actually done it, but if both of them got that, I think they're probably in pretty good shape. So they like oh wait, yeah. Good.
Nice.
What's in it? I'm gonna do real well as soon as everybody wraps up. I'm gonna do a quick. Here's what people messed up on things. So you probably want a pretty clean page of notes for this. Well, if you're planning on doing a retake on the third one. Oh, actually, no matter what, because your exit tickets tomorrow are going to be from that third quiz. So that's won't be your only exit ticket, but that will be one of the ones where I say, do you want a 1, 2, or 3 point exit from that quiz, or one that's super easy, one was kind of mid, and then one that was a little more difficult. So make sure you have a nice clean page for the exit ticket tomorrow, and if you're going to retake that. There's another one. Oh, make sure your name, I forgot to say this, make sure your name comes. Looked at most of them, but every single time we do quizzes and exit tickets, I get some that don't have names. All right, if you guys are still working, I need you to kind of wrap it up. We got to move forward. So. And where is the problem that we use? Oh, ta-da. While you guys are, I think 1 or 2 people are wrapping it up. And change this a little bit. Is it past there? Orange?
Yeah.
Yeah. It's kind of more like that. Super guilty. I got so many guilty. All right, so on the quiz, there was a much easier version than this. It's on again on the triangle angles, congruent triangles quiz, one you just took, I think it was Friday. A lot of kids missed it. It was the easiest question on it. It was supposed to be your gimme point. But a lot of people missed it, which I was kind of shocked at. But they missed it for, again, I don't know. I'm assuming they just didn't really think through it. So, what is true about all triangles? Again, it wasn't just people it was some of the people that know what they're doing. They typically do pretty well. What is true about all triangles when it comes to, we'll say, the interior angle?
That's what I do.
All interior angles, the 3 interior angles of any triangle, will add up to 180. But that is not an interior angle. Don't just take the 3 numbers I give you or the ones with variables and If there's three things and there's a triangle, that doesn't mean you add those three things and set them to 180. That's what a bunch of people do. This would be the interior angle. And that we could use along with the 40 and the 4x effective. Now, it would be a separate variable because we don't have anything there at all. So we'd have to make it like a y. And we can't. There's actually a really complex way to do it, but we'll just say y for now. We can't solve that, but you can't add up 3x plus 55, 40 plus 40 plus 4x subtract 15 and set it equal to 1. What's the concept that we could use? Like, what's the way you're supposed to do this? And it's not the only way to do it, but it's definitely the easy way to do it. What's the concept that we would use here? What kind of an angle is that? If it's not interior, what is it? Can we say it? Perfect. That exterior angle is equal to 40 plus 4x plus 15. That's the concept. The exterior angle, so that's that one, equals the two, it says remote in the book. I will typically say opposite, but I should say opposite. That's the concept you have to use. That's some pretty smart people here. Anybody think of another way you could do it if you forgot that concept? I was so impressed with that. I used to give food. I think I used to give food in your class too. If I gave a really hard problem, I give it like a. I can't remember when I stopped doing that. I used to do a lot, and I don't remember doing it the last couple of years. Oh no, that's not true. I did it last year. First period, you still have that. There is another way you could do it if you forgot that concept. I can't make that y, and I can't solve if it's a whole other variable. Nobody? I thought somebody did. You have a shot at it? No, because they don't add up to 180. Thought you had it. 180 is involved. Oh, good. Look at somebody being super smart. So I need to keep the same variable in it. I know that is a situation, right? Those two angles have to add up to 180. Well, if they have to add up to 180, that angle right there would be 180 subtract 3x plus 55. Now I could say that. So again, that's what that angle equals. Doesn't matter that it looks super weird. That is the measure of that angle. 180 subtract all of that. Now I could add this plus this plus this and set that equal to 180. Again, I don't expect you to know that, but it actually just dawned on me. I didn't do that in the other class that would work. I'll tell you right now, though, the quiz question is way easier than that. And the quiz question, that's a number, and that's a number, and then that's just a y. So either you can remember that this exterior angle is just equal to those two added together, or on the quiz, you could have actually solved in numbers, like come up with a number, not a weird equation expression. You could have just solved and come up with that number. And then you could say, okay, well, if I know that number, I know those two added to 180, so I can just subtract that number from them. A whole bunch of people, though, just added all three of them together and subtracted it from 180. And that did not. They actually solved for that instead of for the exterior. So here's the net. So that was the first big mistake. I didn't really change that one. I did a different version of that quiz now, but that question I didn't really change other than the number. But everybody better get that one. First of all, I literally did the quiz on that, and I didn't change that question. So you should certainly get that one right. Here's the next thing people messed up on. That's fine. I can leave it there. I have to go back and regrade because I actually didn't realize there were two versions. I think I already explained that. I got to go back and regrade. But here was the other thing a lot of people messed up. It said solve for angle something, something, something. Something similar to this. Either a lot of people didn't read the question after they solved for X, they did solve for X correctly, a lot of people, but then they didn't give me what I asked for. I wanted the measure of the angle, not X. So it's kind of like what we were just talking about, Joseph and Delaney. You have to read the question. I want the measure of angle DCB, which is what I just highlighted. So you would have taken the value of X and plugged it in and solved for that angle. So either they didn't read it or they didn't understand what it was asking when they saw these symbols and letters. That means find the measure of the angle itself, not just X. So that was another big one. Not as many people missed that as I thought, though, because like I said, I didn't realize there were two versions for that question. Is there anything else? So on the retake, I took one question off because, well, actually, technically, I took both questions off on the back side, and I made it just one question. So there's no choice anymore, but it's definitely easier than the top question. It's probably about the same level as the bottom question, which wasn't bad. A lot of people got that right. Yeah, so it's 4 questions now. All right, so we're gonna do a quick lesson. Time it took me to lesson over. We'll do a quick lesson, then I'll give you a little time to practice reflections, rotations, because that's your second exit ticket. It's only a 1.1. I was going to give you options, but I ran out of time. First period yesterday, so if I didn't give them options, I'm not giving other classes options. But tomorrow you will get options on reflections, rotations, as well as you're going to be able to pick from this quiz the exact same problem. So if you want to make sure you're ready, just watch that video tonight. I'm giving you the exact same problems. I don't even remember if I changed the numbers or not. Maybe extra tickets. And then was that open? Yeah. I got it. Is. Oh, yeah, here he is. Thank you. Forgot it. No, got it. Yes, got it. Oh, all right. We'll just go ahead and do the new lesson. I don't remember what it was. Go quickly so you get back to the exit ticket. I don't think it'll take too long. Depends on how much trouble you're in. All right, so here's your new lesson. No, this one. All right, here we go. Here's my question. If I have 3 sticks, 3 straws, 3 of anything, I ask you, and I want to make a triangle. You know nothing about this. Right? Nothing about it. Will I be able to make a triangle? 3 straws, sticks, whatever they are. But you know nothing about it. Well, yes, no. Raise your hand. Right hand if you think yes. Left hand if you think no. So I know if everybody's engaged. Do this when I get evaluated. All class long. That way everybody. Hang, right hand yes, left hand no. Can I make a triangle? You don't know anything about these sticks. I have 3 sticks. You don't know anything about them. Can I make a triangle? Damon, what do you think? Raising your left hand. So visually, is your lesson is pretty much just visual stuff. I have this side, right? This stick. Be one of my sides. I don't even remember what people think of it. What is the rate? Another stick. What is the definition of a triangle? What would have to happen? I have to connect the two end points of the green and the gold. Right? They would have to connect. Green, right? It's pretty dark green, but it's green. Oh my gosh. Oh, there you go. Next triangle? A triangle? No. I could not make a triangle, which is weird, right? Triangle had three sides. I had three sides. Didn't work. What was wrong with them? These two were what? They are too short. Here's what I want you to try to write down. What would have to be true about these two short sides in order to make a triangle? You can think of them, what would be true about them, and not really individually, but them as a pair. What would have to be true about the two short sides in order to be able to make a triangle? Well, let's think about it for a minute. Talk about it if you want to talk about it with somebody. I would like, we had tons and tons of time. This is where if you've ever used straws before to do triangle stuff, this is that lesson. If you ever remember doing that. I think it's in seventh grade, maybe, perhaps that you did in seventh grade. I think Mr. Fisher might still do it with straw. I'm taking a quicker version since we have very limited time. We're doing it as a group instead of as individual small groups. What would have to be true? There we go. Almost. What? Huh, look at that. I'm weird. Ah, damn it. All right, raise your hand. If you're like, yeah, I got it. I know exactly what I needed to write down to explain what would have to be true. It's hard to explain. You can explain stuff that I know you're getting. That's why I ask that question every once in a while. And that's why I like putting those on quizzes. I haven't done it in a while. Uh, that's stupid. Huh. I don't know what happened to it. You think you got it? Or are you stretching? Man, did I delete out a page? Yes, I did. Huh. I don't know what happened. My board's been doing weird stuff today, so we'll just use this page here. So, does anybody want to volunteer? That's not my biggest volunteer. Brandon, what do you think? You've been gone for a while. We missed your input. What do you think? Well, they were too short. They were too short. So they were too short. What would we need to do? Make them longer, right? So there's the first part of it. I'm also doing what with them? Like if we think of them as two, when I compare it to this, what am I doing to these two? Like in essence, when I'm folding them down, I'm kind of doing what to them? Math-wise. I think you should say a math operation. This one has a length. This one has a length. I'm doing what with those lengths? Part of the Well, the math, like math means the math operation, add, subtract, divide, multiply. You do what with the links? Ooh, we're gonna get to that in a second. There we go. We would be adding the link, right? I need to know if they're too short, whatever their lengths are, 3 and 5, and this is 10, we'll say, that doesn't work. 3 plus 5 is 8. It's shorter than 10. So what number, let's say that actually works pretty well. Yellow is 10. Right now, this one's 3 and this one's 5. What would they need to be? Just together. What would these two need to be? Well, just together. This is 10. What would these need to be together? Right. That work? Just said you literally just says 10. It work? What would happen if they were both 10? Like a total, if you added them together and they were 10. What would it look like? Because I sacrificed another long pencil for you. That one was 10. I took that, added them together, and made the 10. Folded them down. Put down, stay put better. Folded it down, folded it down. They would touch. They would touch and land exactly on the yellow line. That triangle. That's a line on top of a line. That does not work. That is a line on top of a line, not a triangle. So now, here's your punchline. Ultimately, what you're going to write. What has to be true about this short one plus this short one relative to the long one? It has to be not equal to, greater than. So here's your words version. I call them short side 1, short side 2. Whatever. You could say the mathy version of it is the sum of the two shortest sides. I'm going to say short side 1 plus short side 2. But the key is it has to be greater than the longest side. That's the real key. But you say sum of short 1 plus short 2, regardless, has to be greater than. I would go ahead and add off to the side a little bit just to make sure. Every year, this is the one way that kids miss questions on this because it's not super complex. Cannot equal. Equaling doesn't work. Their sum cannot equal the longest sum. That just give you a line on top of them. Well, if you write that down, I'm also going to write it in another way up here while you're doing that. And we're talking about the lengths of them. I'm not writing length up here, but ah, oh my goodness, what is going on with this? It's crazy. Whoa, I knew it was going to be that. What is going on with this board? Doing this all day long. Ah! Oh, there we go. Some parts work, some parts don't work. So that, go ahead and write that down. That's kind of how you're going to do the problems on the quiz. That's sort of, it's called an inequality because there's not an equal sign greater than sign. That's really what you can use to test out the sign. That's easier than thinking about the words and then trying to figure it out. Well, I mean, it's about the same. So here's how the quiz works and what I do with this lesson. It's two parts to it. This is part one. I give you like it's really just one problem, but it's like 6 problems. I just ask you, if you have 3 sides of these lengths, or 3 sticks, 3 straws, whatever, can you make a triangle? I think I technically say circle all of them that will make a triangle or something like that, but let's say I go 2, 3, 4. You say, okay, well, the 2 and the 3 are my 2 short sides. So I say 2 plus, or again, we're talking about the lengths. I then say that has to be greater than 4 in order to make a triangle. Well, that's 5 over here. And yeah, 5 is greater than 4. So yes, that makes a triangle. That's it for that question. So we say yes or check or whatever you want to do. That sides of 2, 3, and 4 will make a triangle. And then you just do that for all the different scenarios I give you. Circle all the ones that work. That's one of the questions on the quiz. It will be on the quiz next week, mainly just because it's easy and it will help with any of the stuff that it's been a while since we've done. So, any questions on that? I'm about to give you just like 5 of them to go on your own. Okay. All right, so we'll do, let's just start with that, that, that. Oh, I don't even know what's going on. Like, it does this every once in a while. It is horrible today. Something's up. Yeah, this is pretty easy. 3. We'll do. Trying to cover some different scenarios. Ah. Nope. So weird. 9 and I know the last one I'm gonna do. There you go. So for each one of those, tell me yes or no, and you make a triangle. It should not take long, like 2 minutes. Veronica hasn't been here a long time anyway. So. Yeah, Marlon's typically in class, so you must look good again. Jamal, and Jamal. I'm just trying to Gabe. It's from a couple people around me. Probably going to go ahead and get started. Just do them and you can check your answers. But I don't need to. So I'm not going to do each of them. I don't think this is super complex. The next thing is a little more complex, so I'd rather spend a little bit more time on that. So all we do, you find the 2 shortest sides, add them together. As long as they are greater than the longest side, then yes, it's fine. 2 shortest sides are 2 and 5. 2 plus 5 is 7. Does that make a triangle? No. First one is no. 7 is not greater than 12. And if you have questions on why, let me know, but I'm hoping we have this now. 5 plus 5. Again, 5s are the two shortest sides. If you have a duplicate side, you just figure out what to do with it. That's fine. You can have sides that are the same length. You have to figure out what to do with it. 5 plus 5 is 10. Is that greater than 9?
Yep.
Yeah, so that one does make a triangle. Makes a nice isosceles triangle, actually. Next one, 19 is duplicated. So one of those is going to be what? 10 is definitely a shortest. So one of the 19s is going to be a short, one is going to be the long. So again, short, in this case, short plus short. 29, is that greater than 19?
Yep.
Yeah, absolutely. Now, it is possible to have the two shortest not be long. I don't think it's always a yes if you have duplicated numbers. I didn't really give you one here where it's not, but like a 2, and a 10 wouldn't work. 2 plus 2 is 4. That's not very do. Make sure you do the math. Next one, does that work? 12 plus 17 has to be greater than 29. Yeah, what did we say about equal? Cannot be equal, right? You should have written that down. So that's a no. Cannot be equal in that situation is an equal. What about the last one?
Yep. Yes.
So again, just make sure, don't use first two numbers. Every once in a while, somebody will just get in that habit of using the first two numbers every time. We use those two numbers, add them together. Yes, 20 is greater than 14. So that's a yes. That's all there is to the first part of this lesson. Second part's a little tougher. Although the shortcut at the end, if you memorize it, works fine and it's not super difficult to memorize. What if I gave you these sides? 11, 20 is one of that's a 20. Better version of that. But then I tell you, I don't know anything about the third side at all. I have no idea what the third side is like. And I say, what I want you to tell me is what length sides for the third side would be able to make a triangle? Like what would work? And there's an infinite number of them. So you have to give it to me as a range. I'll show you in a second what that is. So see if you can figure out parts of it. What would X have to be in order to be able to make a triangle? It's again, it's not one number, it's a whole bunch of numbers will work. I guess I can kind of show you what I mean by range. So you have X is going to be something, right? Let me just ask this. Does one work? Can X be one? No, right? X can't be one. 2, 3. Okay, so there's a bunch of numbers that are too low. So eventually you're going to get to a number that works. So X is going to have to be bigger than some number. It has to be bigger than 1, 2, 3. You'll get the number. Does 100 work? Remember, now X is the longest. Before, we were saying X was one of the shortest sides and adding it to 11. 20 was the longest. Now, at some point, X becomes the longest side. So you got to figure out what's the biggest value X can be and still work. So X is going to wind up having to be less than some number or the other. Well, I'm going to let people think about it and I'll. So think about what the two thresholds is kind of what we call, but like what's the lowest value X can be and the highest value X can be. And you can just plug in numbers like I was doing 1, 2, 3 until you get to like, oh wait, here I am, that works. And then do the same thing on the other end. What's the biggest X can be before it stops working? This is what I said might all, or I think I said it, might also be an exit ticket tomorrow. Maybe this would be the 2 point, and what we just did before would be the 1 point. I get different. Along with, there'll be one, like I said, on the third quiz, the green quiz, triangle angles, and then there'll probably be one again on reflection, rotations, and reflection or rotation. And that will probably involve maybe having two different point values or three, probably two different. All right. So if you keep adding to the what I started off with 1 and 2, right? 1 didn't work because 1 plus 11 is 12. That's not bigger than 20. 2 didn't work. 3 didn't work. We get up to about 6 and we start getting closer. Well, that's not, oh, I don't know where I would put 2. That is not greater than 20. 7's not greater, 8, not. And then we get to this guy. Does that work? Cannot be equal, right? So what's our lowest number we can be at going to be? 10. Raise your hand if you think that's wrong. 9 didn't work, right? Why is 10 not the right answer? Where am I at 9? Equal, right? Dead even, exactly equal. You telling me there's not a number bigger than 9 before you get to 10? Decimals. Why do you guys always forget about decimals? Decimals are numbers. As soon as I get, if you know your science, you'll get this. If you don't, I'll give you a number version. As soon as I get 1, because I'm right at 20, right? As soon as, and this was X, 9 was X. As soon as I get an atom larger than 9, not even a number, like no number exists that is that small, but as soon as I'm any bigger than 9, it works. I will now be greater than 20 on this side. So your threshold is actually 9. Even though 9 itself doesn't work, we take care of 9 not working because there's no equal sign underneath. So as soon as I get any larger than 9, like I said, a single atom or a number version, 9.0000000, and you can keep writing zeros forever, and then finally put a 1, that works. It is going to be bigger than 20. So that is your threshold on the left. We take care of the fact that it doesn't work by not putting an equal sign. Now on the other end, X eventually all of a sudden becomes the big side when I get to 20. Well, technically, when I get over 21, anywhere over it, I'm going to say, I'm sorry, anywhere over 20. I'm going to say 21, though, just now that I get to 21, or now that I want to use 21, that is now going to have to be, so X is now the longest side. So I need to start adding 11 and 20, and I'll just add those over and over again because they're going to be the shortest sides forever now as I make X bigger. And so again, does that work? That doesn't work. No. That works. Yeah, 11 plus 20. Now those are the two shortest sides. They're bigger than 21. I keep increasing this. Does this work? Oh, I can't change those. I'm sorry. That worked.
Yeah.
Yeah, 31 is greater than 30, right? Again, these two short sides don't ever change again. Does that work? No, cannot be equal, right? So as long as X is less than 31, because 31 is right even. These are even with those, and they have to be greater. So if I just make this a tiny bit smaller than 31, then these, which are 31, would work. So X has to stay less than, I'm going to erase that. Is anybody writing that on right? So X has to stay less than that 31. So again, you can go through that whole process and you'll always get the right answers if you understand like how that threshold works. Let me ask you a question on that. Real. Look at my original numbers that I gave you, along with the X, the 11, 20. How do I get 9 using 20 and 11? I just subtract them, I get 9. How do I get 31 using 11 and 20? That's like shortcut version. Again, I don't love shortcuts. If you take the 11 and 20 and you subtract them, it will always give you your lower end pressure. And just remember, no equal sign underneath. That's the way they could trick you on multiple choices. Put an equal sign under there. If you take 11 and 20 and you add the 11 and 20, it will always give you the higher end. Again, remember, and not be an equal sign under there. Has to be greater than the lowest end, less than the high. All right. So exit ticket's not going to take long at all. You have quite a bit of time. I'm going to do a real super fast review, and then you can practice a couple if you want. Yes, you could get out your Excel when I get done, but on reflections. Yeah, there we go. Perfect. We said reflections are like mirror image. The image has to look the same on both sides. What is the starting point? Like not literally the point, but like what's the first thing you have to, they'll give it to you, but what do you have to understand how to do on a reflection? Graph what? It's called. Huh? Well, before you move the points, you got to know what? What do they have to give you? Line of reflection. You've got to know how to graph the line of reflection. If you do that, you're good. On any of them, whether you're taking that quiz, retaking the second quiz this week, whether you're doing the exit ticket, whether you're doing the more difficult exit ticket tomorrow, line of reflection is always the beginning. So let's just go over those. I'm just going to draw a graph. I'm not going to bring one in. So if it says the line of reflection is the y-axis, what are you going to darken in? The y-axis. The y-axis is labeled. Don't get them confused. That is the y-axis. You would darken in the y-axis if it said y-axis. And then take your point, count toward the y-axis. You always move toward the line of reflection. Some people got confused on this quiz because the image crossed over the line of reflection. So they went the same direction with every point. You always count toward the line of reflection and then keep going. If it crosses over, then you'll go different direction depending on the points. But just always follow that rule. For this, yes. When y isn't, yes, you'll always be going because the point will be somewhere over here. So for a y-axis, you'll always be going horizontal. But it might be that you go left with, like if it's a whole image, one point might go right, but one point might go left. But just always go toward the line of reflection. If it says x-axis, reflect over the x-axis, what are you going to darken in? The x-axis, right? The x-axis is this, and it's labeled. Should never forget which is which. Some kids did though, or they didn't read the question. It's one of two. So we'll make that green. So I darken that in, and again, now I'd be counting either up or down, but I count forward the line of reflection and then keep going to the other side. What if it is x equals a number? What do we say about that? That's the one I said you gotta remember, because if you remember that one, the other ones can be figured out, I think. So x equals a number. I'm just gonna pick, I guess, negative. Will be a vertical line. So x equals a number. Line of reflection. So make sure you go to the line of reflection and then keep going. Some people, like if the point was over here and they were doing x equals a number, they stopped at this and then started counting again. So the y and x axis have nothing to do with the counting if this is your line of reflection. You always count to the line of reflection. What if y equals a number? Yeah, that would be, if this is x equals a number, it would just make sense. Y equals a number would sort of be what you could say is the opposite. It's technically it's really perpendicular to it. What can we use for that? Oh, I would guess we could use gray maybe. So y equals a number left and right. So y equals a number left and right. What about, and these were the two, we said they were a little trickier. Y equals x. What was that? Dude, we kind of have exhausted the up or down, left and right. So if that helps you remember, that's when we have to move to diagonal. So it is a diagonal line. I don't know what colors to use. Oh, we'll do it dashed. I think that's what I actually did on the. So diagonal, good one, but diagonal going up left to right for y equals x. Now, when we count that, this is actually what Aiden came up with. We count for that, it's a little different. We can still count along the grid lines going toward the line. I told you about a diagonal way. I'm not even worried about that because I didn't draw in diagonal, I didn't draw in grid lines. But we said when you count toward this, it'll work. Just don't keep going straight through. Or if you're going up, don't keep going straight up. You have to make a turn, left turn or right turn, and follow the grid lines up or down, left or right. So my point was down here, and I counted up, I would make a left turn and go left. It's got to be kind of like perpendicular to the line of reflection. Works, remember you can't keep going straight through. What about y equals negative x?
It's diagonal.
It's diagonal, but how is it different? What's the different part of that? So, but it would go how? Yeah, I would start up there and go down, right? Let's do that. We can still, yes. So that would go kind of diagonally like that. That would be y equals negative. Again, as long as you know, and I'll just tell you, it's a 1 point win, so it's one of the pretty easy ones. As long as you know that, that's a quick review for exit ticket today, exit ticket tomorrow, review for the second quiz up there, which I also just did the quiz, so you can look at that. I'll give you, if you want to try to do a couple, if you have some old graph paper and you want to do a couple. If not, I'll pass out graph paper and you can go to your book. There are some problems in the book. Back on page, I don't know. We actually really just did IXL. So does anybody have, well, I'll just, if you want me to do one, does anybody want me to do one up on the board? What do you want? So you have like when it's an image and it crosses over the long function. I'll do it. You only have to do one single point on the exit ticket today, so that won't come into play. But I will do it because that, for people that are going to retake, especially if it's today after school, that was something that kids missed. Oh, I'm going to have to bring in a graph for sure. Graph. All right, so here's what Delaney was saying. We'll just, to make it simple, we'll do y-axis so I don't have to shrink this down. If I told you to reflect over the y-axis, again, we can go ahead and do this part. That's the y-axis. Oh, didn't really. Oh, there we go. So that's what I would do first, darken that in. Now, let's say the image looked like this. Typically, triangles are pretty common, but it could be any image. So that crosses over the line of reflection. Some points are on the left side, some points are on the right. A lot of kids got confused on like, wait a minute, like, how do I do this? So you just do the same thing we said do. Take each point individually, count toward So again, I'm just looking at B. I'm ignoring everything else. I don't care about the lines, the other points. Point B moves 1, 2, 3 to the right toward the line of reflection. And then 1, 2, 3. Is this what you're talking about? Now, and I went right. Now I'm going to go over this. I just go toward the line of reflection still. Nothing changes. I don't keep going right every time. I count toward the line of reflection. 1, 2. That's an easy one, so I'm not going to draw in the little things. You just always go toward the line of reflection and keep going. And if you need to make a right or left turn, go like y equals x or y equals negative x. So again, 1, 2, 1, 2. And for any line of reflection, y equals x, y equals negative x, x equals a number, y equals a number, you could have an image that crosses over. So that could happen for any scenario. Now you just connect the new points. I would always connect the points. A lot of people didn't connect the points. If you connect them, you should see it kind of looks like a mirror image. I would connect them. Like you should see, well, if I folded that down the green line, yeah, it looks like these 3 points would kind of land on those 3 points. And we didn't really talk a lot about that, but if I had, you probably would have seen when you, in an image like this, when you always went in the same direction, it didn't look right. All right. You can go ahead and pack up. We'll take it early unless anybody else wants me to do. It's only 1 point on the exercise. Like most people were done by the time I passed half of them out. They put a paper clip on these. And these. Some of them. Yeah, should I think. Uh, uh, that one. No, you don't have to write the X, Y, or anything. Just move the. I mean, if you want to, you can. But I'm mainly expecting to grade.
The new ticket.
Yeah,
The ticket.
yeah, do both of those. Yeah, just he was just asking, do you need like okay, you need to rank the X and the Y value? No, you don't. Um, you get the stuff we've done already. Yeah. Make sure your name is on it. I still every quiz, every exit ticket. It's some from people that sometimes they're actually even pretty good, which is a shame. I figure it out. Especially on me. Hey, good job. You've never done that before. That's a good issue. Yeah, new thing.